Hello friends, I'm Jagdish Park Associate. Today's topic is strength of materials. So in strength of materials, I'll be explaining a numerical problem from the chapter bending stresses and shear stresses in beams. So before going to this video, please press the subscribe button of our channel, the Mechanical Engineers team, and also click the bell icon so that you'll get the notifications for new videos. So let's begin. First I will read the question. A beam with rectangular section of width 30 mm and depth 60 mm is subjected to a bending moment of 800 Newton meter. Determine the maximum bending stress induced in the section. Now I will analyze the question. There is a rectangular beam. The width of the rectangular section of the rectangular beam is 30 mm. The height or depth of the rectangular section of the rectangular beam is 60 mm. The rectangular beam is subjected to a bending moment of 800 Newton meter. Due to this bending moment, the rectangular beam will tend to bend, due to which the bending stresses will be automatically developed inside the rectangular beam. So in this question, we have to find the maximum bending stress value. Okay. Now I will list out the given conditions. First, the height or depth of the rectangular section of the rectangular beam is 60 mm and it is taken as H. Second, the width of the rectangular section of the rectangular beam is 30 mm and it is taken as B. The bending moment applied on the rectangular beam is 800 Newton meter and it is taken as M. Okay, so by using these three conditions, we are going to find the value of maximum bending stress induced or developed in the rectangular beam. Now I will move to the solving technique. First, we will find the value of moment of inertia, which is taken as I. First of all, why we have to find the value of moment of inertia? Generally, when a torque is applied on a mass, the moment of inertia will be automatically induced in the mass. Therefore, the mass will tend to rotate. So similarly here, bending moment is being applied on the beam. Therefore, the moment of inertia will be induced automatically. Thereby, the beam will tend to bend. Okay. So for this reason only, we are finding the value of moment of inertia. Okay. For finding the value of moment of inertia, we will use the formula of moment of inertia of rectangle, and the formula is I is equal to BH cube whole divided by 12. Okay. So in this formula, we know the values of B and H. So just substitute the values. So the next step will be I is equal to 30 mm into 60 mm whole cube whole divided by 12. Here 60 mm whole cube is 2,16,000 mm cube. So the next step will be I is equal to 30 mm into 2,16,000 mm cube whole divided by 12. Now in this RHS I am going to split the numerical terms and S units. So the next step will be I is equal to 30 into 2,16,000 whole divided by 12 into mm cube. So here 30 into 2,16,000 whole divided by 12 is 540 into 10 power 3 and into cube is to the power of 4. So the next step will be I is equal to 540 into 10 power 3 to the power of 4. So the moment of inertia induced in the beam due to the bending moment of 800 Newton meter is 540 into 10 power 3 to the power of 4. Now we will find the value of distance of extreme fiber from neutral axis, which is taken as y. First of all, why we have to find this value? Why? Because in this world, many material has its own neutral axis. So similarly, this rectangular beam will also have its own neutral axis. Okay, and in this world, many materials are made up of fibers. The fibers may be in the form of layers or wires, etc. When these fibers are attached together, it forms a component. Okay, so similarly here, the rectangular beam is made up of layers, group of layers. When these layers are attached together, it forms a rectangular beam, and these layers are known as fibers. Okay. So here we have to find the distance between the neutral axis and the lost layer or extreme fiber. Okay. So for finding the value, we will use the formula y is equal to h by 2, and this formula is particularly applicable for rectangular section only. For circular and all, it will be different. Okay. This is not a universal formula. This formula is applicable for rectangular section only. Okay. So in this formula, we know the value of h. So just substitute the value. We get y is equal to 60 mm by 2. So 60 mm by 2 is 30 mm. So the next step will be y is equal to 30 mm, which means the distance of extreme fiber from neutral axis of rectangular beam is 30 mm. Now we will find the value of maximum bending stress, which is taken as sigma b, and the formula for bending stress is sigma b is equal to m into y whole divided by I. In this formula, sigma b is bending stress, m is bending moment, y is distance of extreme fiber from neutral axis, and I is moment of inertia. So in this formula, we know the values of m, y and I. So just substitute the values. So the next step will be sigma b is equal to 800 Newton meter into 30 mm whole divided by 540 into 10 power 3 mm to the power of 4. So here meter is nothing but 1000 mm, that is 10 power 3 mm. So I am going to replace this meter by 10 power 3 mm. So the next step will be sigma b is equal to 800 into Newton into 10 power 3 mm into 30 mm whole divided by 540 into 10 power 3 mm to the power of 4. Now in this RHS I am going to split the numerical terms and S units. We get sigma b is equal to 800 into 10 power 3 into 30 whole divided by 540 into 10 power 3 into Newton into mm whole divided by mm to the power of 4. Here 800 into 10 power 3 into 30 whole divided by 540 into 10 power 3 is 44.44, and mm into mm is mm square. So the next step will be sigma b is equal to 44.44 into Newton into mm square whole divided by mm to the power of 4. In this RHS, when mm square is divided by mm to the power of 4, the mm square gets cancelled and mm to the power of 4 will get converted to mm square. So the next step will be sigma b is equal to 44.44 Newton per mm square. But Newton per mm square is megapascal. So the next step will be sigma b is equal to 44.44 megapascal. Okay. Which means the maximum bending stress induced in the, the maximum bending stress developed inside the rectangular beam due to the application of bending moment 800 Newton meter is 44.44 megapascal. So friends, this brings an end to the explanation part of this video. I hope you all would have understood. If any doubts are there, please do comment in comment box, and remember to like, share and comment on our videos. Thank you friends.